Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zubair bin Mokhtar, and today I will present my review study on the topic of green synthesis of imines by employing deep eutectic solvent or DES as alternative solvent. So, first of all, we'll go to the objective of the study. The first objective is to propose an alternative solvent for imine synthesis. The second objective is to review the existing study on the employment of DES for imine synthesis. And the third is to discuss the important parameter in imine synthesis by using DES. So, let's go to the introduction. So, imine. Imine is a compound contain carbon-nitrogen double bond. As can be seen in this picture, this is the general structure of imine. Imine also has unique characteristic, and because of that, it can be applied into various fields such as medicinal and also modern chemistry. Imine also can be synthesized with the condensation of carbonyl compound with amines. For example, ethyl amine can be added into aldehyde solution to produce imine, and also Dean Stark distillation apparatus also need to be used to remove the water. However, this conventional method has a huge drawback, such as the use of the hazardous solvent. For example, methanol is used in imine synthesis, and methanol also is toxic, volatile, and flammable. And what's more important, the methanol can affect human health and also the environment. And because of that, this is the main concern in this study, which we need to replace the use of the hazardous solvent in imine synthesis. And one of the best candidates to replace the hazardous solvent is deep eutectic solvent. So let's get into the deep eutectic solvent. Deep eutectic solvent is a class of liquid that are liquid at ambient temperature and also composed of 2 or 3 components. And this melting point is lower than their component, and it can be prepared by mixing hydrogen bond donor and also hydrogen bond acceptor. For example, the hydrogen bond acceptor also called as organic salts, and the most common organic salt is choline chloride. And this picture is the component, the potential component that can be mixed to produce DES. And because of that, DES can be used in the wide variety of field because the potential component is also wide. Other than that, DES also is cheap, non-flammable, and easy to prepare. Next, we will go to the main part, which is the DES development in imine synthesis. And in this part, the important parameter will be discussed. So we will go to the first part, which is the yield. AZC and ADC in 2015 have synthesized imine by using DES, and they reported 95% of the product yield. Other than that, Jadab and Shankaling in 2013 also have reported 94% of product yield. And last but not least is Gioia et al. Also reported 75% of the product yield. All the study shows that by employing DES as a solvent, we can get a high yield for imine synthesis. Thus, the yield is not an issue. Next, we will go to the recyclability. Recyclability refers to the potential of the solvent to be reused at the end of the reaction. Q et al. In 2020 reported that DES can be used up to 3 cycles. And also Muyen et al. have reported DES can be used up to 5 cycles without any significant decrease in the product yield. This shows that the DES can be good potential to be a green solvent because it can be reused again up to 5 times without any purification and also without any significant decrease in the product yield. Next, we will go to the next part, which is the reaction time. However, based on the review on all the paper, the reaction time is consistent. For example, AZC and ADC in 2015 have synthesized benzylidene alanine in 2 hours. However, while Jadab and Shankaling in 2013 have synthesized phenyl hydrazone in 5 minutes. As can be seen, there are huge gap with these 2 studies. To explain the better context, for the conventional method, benzylidene alanine need 2 hours to be prepared, while phenyl hydrazone need 30 to 2 hours minute to be prepared. This shows that the reaction time depends on the imine itself, and this have not significantly affect the reaction time. Next, we will go to the scalability. Gio et al. Have conducted the scalability study, and the product yield is 87%. And Jadab and Shankaling also have conducted and successfully conducted the successive scale-up reaction. Thus, this shows that this has the potential to be implemented at industrial level. And last, we will go to the limitation. Apart from all the good part, the high yield, the good recyclability, the scalability potential, there's also a several limitation, which is the this was reported to be toxic towards several species, and the biodegradability also is inconsistent. First, we'll take a look at the toxicity. Hayat et al. Has conducted toxicity tests on deaths toward brine larvae, and based on the result, the larvae only live for a short time, which is 0.15 until 10 minutes, while in the CH choline chloride solution, it can live up to 47 minutes. And also, when et al. Have conducted toxicity tests for deaths through the garlic cell, and based on the result, deaths have shown it can disintegrate and deform the nucleus of the root tip. As can be seen in this picture, A is normal, the garlic in the ionized water, where D, E and F picture is the garlic in deep eutectic solvent, which you can see in picture, it destroy the cell. And last but not least, we will go to the biodegradability. According to OECD, a compound with biodegradability level above 60 only will be considered ready biodegradable. And when et al. in this study, only 2 of them out of 8 deaths have found to be readily biodegradable. However, a study by Rasadif et al., they reported all of the tested deaths have higher biodegradability from 86 until 98%. Thus, there is inconsistent between these two studies, and more study need to be conducted. So we have come to an end. For the conclusion, deaths has shown a great potential to be alternative solvent for immune synthesis. However, the two limitations, which is the toxicity and biodegradability, need to be resolved. And my suggestion is to conduct more study and more research on death's behavior toward organism in order to establish the non-toxic solvent, or to lower the toxicity of deaths toward organism. And if you succeed, then deaths really can be an alternative solvent for immune synthesis. So that's all from me. Thank you.